Hello everyone, I'm Philip Manilov. Today we'll be seeing another stone manufacturing facility, Hutton Stone.
The top 1/3 of it is that really fractured material, and that is where all the rubble walling came from. This thing represents about a £500,000 investment. No more of drilling one hole, chuck a load of black powder in it and see what you get. It's just like a big cheese cutter, really. Once the moisture dries out from it and the air gets to it, it changes and it resolves many of those really aggressive visual things that you find so horrific in the first instance. Super significant in terms of the built heritage of the whole of the central belt of Scotland, particularly Edinburgh and Newcastle and that general area. So as the Industrial Revolution got going and as the railways got going, this area, suddenly railways came across it and crossed the border at Berwick and across there, and we then start to see the quarries in the central belt of Scotland start to become relatively exhausted, in that they've been producing stone for several hundred years at this point, and the cities are growing really quickly. Edinburgh's growing really fast, and so the quarries that were out in the middle of a field are suddenly now surrounded by the new town. So that's all happening, at which time the railways arrive, and the investors in the railways are often the people that own the land. And so they wish to demonstrate the ability to carry heavy weights long distances, and they wish to profit from that. And so they start quarries in these rural locations, which previously to that had only supplied the material within their own immediate area, as far as a horse and cart could drag it. So that is a big change. But remember that we talked earlier about the first steel building with stone cladding on it, 1890. So in this area there were about 7 or 8 different really significant quarries, Darney being one of them. Darney starts operating around about 1890. So that's significant because by 1919 we have cavity walls and we've got no use for rubble. Now look at the waste heap that we can see from this particular quarry. So when we look out, we can see that this is a crag here, and they've basically come in off the end of this crag and started throwing the stuff they didn't want away from them and worked in that direction, okay? From about 1890 onwards. And what that tells you is that from this point, rubble has become irrelevant, and block that is discoloured or indifferent or too small for the bigger panel sizes that we're now starting to want to hang on our steel frame buildings is all rejected. So the lesson of that is all within these waste heaps, and if we were to walk right round, they go on and on and on. And you can see these narrow fingers that sort of come out. That's where the trolleys would go out. There's little metal trolleys on rails, and they would tip off the end. So wherever you see these in rural locations, they are the natural scars of industrial working in that way. So now you can become experts at quarry spotting in rural areas. Buildings. Yeah, that's my idea. So we can build it here, right? In a quarry like this, we go down about the same depth again, as you can see now. The top 1/3 of it is that really fractured material, and that is where all the rubble walling came from. The next third down to the level of the bulldozer, is massive block, but it's quite colourful. So that's where all of your walling products came from after that, your lesser material. And then from there down as deep again is again massive block, but it's quite clean. So that's where all of your front door stuff came from. So within most quarries, there is this really sustainable cycle of those things, as we've talked about, and we've talked about the carbon cost of those things and the cost, the financial cost. But you can see that in order to make this thing a really sustainable thing, you have to engage and use all of the materials to be able to do that. And that's part of what this process is. The new drill rig, which is this machine over here. So this thing represents about a £500,000 investment. This is its first week here. What this will do, so quarrying in a place like this, where you can see the drill marks, that is where we drill, like on a jot, you know, like on a jotter pad where you can tear it really straight because of the little holes. That's just what we're doing with quarrying. Okay, and where you can't see those, that is because the earth has given us a natural joint. So in effect, quarrying is drilling holes to join up where all the natural joints are. So lengths and widths and heights of block are dictated by our ability to drill holes after whatever nature has left us with. This machine, so prior to that, we've got another drill rig up there that we would have used before, but this drill rig will drill twice as quickly vertically, but it will also, because of the nature of the arm, drill each drill plan 3 times quicker, and it will do that using 30% less fuel than our single machine did use to drill one hole. So I don't know how many doubles that is in terms of benefit. And the other thing is, because we can now drill much cleaner, much straighter, much more accurately, we can use 50% less explosive in that process to get that out. So that's 50% less cost of explosive, but it's also 50% less stress on the block. So all of those factors make mass production of bricks and mass production of walling and other masonry products more viable still. So you can't just put in a brick line, you have to put in the bit at the beginning, you have to put in the whole process. It's like when we looked earlier at why do you have so many different saws. It's because each job requires a different approach to make the most out of what nature has frustratingly left you. Okay, so we'll go up, we'll wander up here now. It's a little muddy, but mostly, I think I saw one pair of white framers earlier. There's one famous pair of white framers.
The Air Force Ones, they're fine. They
yeah, they're
can go in the bin.
bulletproof. Fair enough. Okay. Go to whatever you want, like you can put, at the moment there'll be a 4 or 5 meter rod in there,
Yeah.
and then you could take that out and then you could put an 8 meter rod in, go back up and go again. So the difference for us is that we were restricted before to about 3 meters max. Now we could literally drill from up there down to the bottom to whichever bed we want to go to, whichever one of these natural joints. So we can take this quarry in much bigger pieces now, which is an economy of scale, which means that when you come back here in about a year or two's time, all of these fragmented areas will be back. Because the other thing is that if you drill as good as this, not only is the block good that comes out, but so is the face good that you've got. So that changes your decision-making process. Rather than looking at a face like this and making a decision, you're suddenly controlling the whole of that, and that makes UK quarrying look far more like European quarrying. You know, at that point where the UK, because of the price of coal, gives up on its stone, Europe doesn't, and that's why the European quarries are more developed, are cleaner, better. And so this is the first one of these machines in this country.
All right.
And this is us saying no more of this, no more of drilling one hole, chuck a load of black powder in it and see what you get. This is absolutely so this will transform this quarry over the coming year, 18 months.
So what about wire cutting? Because I've seen some, like in Carrara in Italy, they
Sure.
drill this and
Yeah,
then they
but remember
put a
how
wire.
we talked about in the UK, lots of smaller different geologies have all smashed together to form
Right.
the UK. So that means that our geology is much more challenging. It's much more. It's not one thing in great big solid pieces. So in Carrara you can cut a 1,000-ton block because it's all the same, perhaps with no cracks in it. Here that is not the case.
Not okay. Okay.
Now in limestone production in the UK, chainsawing, wire sawing and those things is economical. But in sandstone, because of the abrasive nature of the material, drilling is still the optimum balance between wearing machinery and equipment, cost of consumables and output. So it's about the geology, it's about the behaviour of the material.
Nice.
What you can see by immediately doing that, so we've split it in the middle, and that will allow us to turn that on the circular saw and start to cut now very actively, 90 degrees rotated. So you can already see here, just put your hand there, you will see that the stone that presents itself in raw fashion becomes very different the moment that we start to split it. And a saw like this will have two cables, so they will be loaded with blocks. Each one can automatically trundle in, and then this large diamond blade with water filled on it, it runs like this and drops at about 1 metre per hour through a block. And it can drop across the cut or comes back into a situation like this. The sediment and the water goes down into here, the pumps bring that up through here, and it injects a thing here called flocculant, which attaches to the sediment, which makes it heavier. So it goes up into the top of here, into a central core, into the top, and because the sediment is now heavier, because it has the flocculant added, the sediment falls to the bottom of the cone in here, which allows for then clean water to head over into the clean water tank to be recycled again. That sediment is then pumped up through this pipe into a set of large tea bags, which you can see are filling up again and pressing again. You'll see that they'll slowly close up, and then it will suck more sediment up into there. It will press any of the remaining water out of the pan, which will send back down into here to continue the process of recycling the water, and we will press out that sediment. So we will produce here about 2.5 to 4 tons a day of that material. So the best thing that we can currently find for that is that a local company that makes kind of like the big grain wall, kind of like big Lego blocks, those sort of retaining wall blocks. They use this as like a bulker, a bulking ingredient within their sand and mortar, cement and whatever. To a certain extent, it does, yeah. It does. But given the utilitarian, I mean, it doesn't really matter, it doesn't matter. But the point is, our water bill here, our turnover here will be about £3-ish million worth of masonry a year. Our water bill here will be 450 quid a year because of our water recycling process. It's just like a big cheese cutter, really. Diamond wire. The blocks come in, the trolley trundles in, and we can cut. This thing can take up to 5 wires. It's like a multi-wire thing. But again, it's for that primary sawing process, you know? The loaf of bread analogy that we used earlier is what we are achieving with that stuff. So you can see colossal sized blocks can be put into there. You know, whatever we can lift really can be put into there. And we start into that process of producing the material. Interestingly, when the stone is first cut, it's creamy coloured to pale, but let it weather for a little while and it goes buff. And that is the truth with any natural product. It takes time, the air changes, it's been on the ground for a long time. Once the moisture dries out from it and the air gets to it, it changes and it resolves many of those really aggressive visual things that you find so horrific in the first instance become irrelevant. Okay, so now we will carry on and we'll look at some of the other, so these are 2-metre blade saws and 3-metre blade saws. So like the big circular saw you saw earlier, but now they're doing a different job at this plant. They are taking the primary slab and they are making it into a secondary product ready to make it into either a brick or a building block. The product is ready to go, and what we've done by doing that is make the changeover from one saw starting to resetting it again to go automatically again. We've changed that from about an hour and a half to about 15 minutes. So these are all these little things that affect carbon footprint in the end, and now as an industry, or some of us, are starting to think really only about anything that we can do to achieve efficiency, both manually and also from a carbon footprint point of view. This is brick manufacture, and this is walling manufacture here. We've got both lines running and we can just walk around and see them making each other.
Right now you're seeing a conveyor belt where they're putting large slabs of stone and they're cutting them first lengthways, and then later on these long pieces are being pushed down the line, and you will see a machine is cutting it sideways to create brick shaped essentially stones. And you will see that they're not even, so the parts at the front and the back, they're being cut off first, and that's how they're producing this stone bricks.
reinforced split-faced walling, so it looks in effect like Cotswoldy walling. And it's 100mm on the bed, or it can be whatever bed width you ask for, but as a stock product it's like that. Basically lots of housing in Northumberland and Lancashire and Yorkshire to a certain extent uses that stuff for house building. It's full of colour, full of vibrant colour, because the colour range in the quarry is quite broad. So you use the posh stuff around the front door and you use this for the general wall. You'll see this being made just around the corner with secrets. Absolutely rejected any selection process. You remember we were talking earlier about the need for the architect to feel aesthetically in control, and us now to throw that back at them and challenge them about that. However, what we decided was that you saw the bricks coming off the line on the end of the conveyor belt. You know, like on a computer where you're having to get into something and it says, prove you're not a robot, by telling me how many bicycles there are in this grid. So, the bricks come to you in like a grid fashion, and you have a moment to decide how many bricks have got brown in them. Because the one thing about Darney Stone is it's got this really challenging stuff, and this stuff is always rejected in posh masonry because it looks like somebody spilt hydraulic oil all over it. Okay, so if you put that brick in there, and bear in mind I can't control how much of it is out there, and you have your first Arctic load and there is 10% of that in there, that would be fine. But what happens if your next lorry load is 40%? Because this natural product just keeps giving a way I don't want it to give all the time. So what we elected to do was not throw them away, but we elected to select. So we now have Darney stock bricks, which when weathered, remember when you look at these, how it buffs up, will end up looking in effect like a London stock brick. Okay, so there is Darney stocks. These are now Darney browns, and they are interesting, we think, because actually, funnily enough, they look really old all of a sudden. They look industrial. And so what we will do is we will market those as a different product, or you can buy Darney blend, but it means you can control the blend, because you can say I want 5 pallets of that to 1 pallet of that. And that means that your building doesn't get a blotch of like you know, loads and loads of that, and then suddenly your bricklayer sticks all of that in one space. So it gives you the chance to blend, which we can't blend here if we're to be efficient with our production, because that brown stripe, a slab will go onto that saw and it will be perfectly clean, and right through the middle of it there'll be a brown stripe running diagonally right the way through it. So those bricks are perhaps 10%. You can't say when they're going to come and when they're not, but it does give us control. So we're not throwing any of it away, but we are giving you at least some aesthetic help.
Does that mean they're more expensive to buy?
Do you know what? When I decided that this was how it was going to be, my staff said to me, what if does that mean they're going to be really, what if we can't sell them, or what if we haven't got many? And they said, well, if we have hardly got any and people really like them, they'll be more expensive, and if I've got thousands of them, they'll be really, really cheap. So like, it's just whatever the market will do. But because this is a new market, although in fact the market isn't new at all, it's just a brick, and it's just my modern suggestion on what a piece of rubble is. If we think back to this whole conversation we've had today, you know, that's all it is. Although it's a new concept, it really isn't, and it's completely interchangeable with that clay brick. There's nothing that you need to think about other than don't use that brick, use that brick, or whatever you want to do.
Are they heavier?
They are marginally heavier because we don't have the frog in them. So the frog is the groove in the top.
Yeah, they must have a much better specific heat capacity as well, because they're not empty inside.
So our compressive strength is far more like an engineering brick.
Yeah.
So a standard brick is maybe 14 MPa to about sort of 20 to 30 MPa. So these Darnley bricks will be about 60 MPa, and an engineering brick would be sort of 60 to 75 MPa. So they are slightly heavier, they are, but you know, they're going to be there for hundreds of years. So, and then the thing about mortar, so you have choices to make with mortar. We would always say with anything, if you can use lime mortar, you are the ultimate sustainability warrior, and that is great if you can do that. There is some cost and some building time implications to that decision, but nevertheless it makes your material completely recyclable afterwards. If you can't do that, then a standard N3 mix, which is 6 sand, 1 cement, 1 lime, or we would suggest actually maybe 6 sand, half a cement, 1 lime. So a very weak mix, if you really have to use cement, would be what we would suggest you would do. There is inevitably going to be pushback by bricklayers who want a slightly lighter brick and want to be able to build thousands a day. They'll be able to build a few less of these a day, perhaps because they're a little bit heavier and because of the mortar. But there's a cost to everything. You know, we have to own our choices. So the bricklayer might want to reflect on the fact that perhaps he'll get to switch his electric lights on for longer if he just looks after his planet a bit longer. But maybe he won't be bothered. So that's certainly, first off, it's up to architects and the industry for us to provide the materials to give you the options, and for you then to see how you feel about those and to use them in exciting ways if you can, or to introduce them into social housing. We're quite keen. We think we've got some social housing in these now. And of course, what Amin Tahar is saying to me now, yesterday he was saying to me, was look, we've got a job in London, social housing. He said, I want any brick, I don't care what the colour is. So he said, don't throw any away, I just want it as cheap as I can possibly get it. So we're going to do that with it. We're going to prove the point and do that. So in that case, we might, I think what we'll be inclined to do is supply him those, but I think we'll make a feature of those, just to prove the point. They just take them straight from the saw like that and they will dress them themselves. Sometimes they will have us polish them, and Cabin's doing some of that now. And sometimes they will go into our masonry block to get shaped. But you can see in here, rain. So the nice time to talk about rain. What is this shot at? Okay. So this is an actual job for HDS, Historic Environment Scotland. Now interestingly, they are much more open to rain because they understand that if you accept all rains, if you said, well, I want them all to be like that, that means I have to throw all these away, which makes that one very expensive. But if you accept rain and accept when it's wet and when it's fresh, it's the most offensive it's ever going to be. And that natural weathering, appropriate weathering, gets rid of all of that over a period of time. You can drop your carbon footprint massively by accepting that, because it means you don't throw it away, and you can also drop your cost base massively in that process as well. So it's worth thinking, and we'll look at a little bit of that later when we look at some weathered materials. But understanding our built heritage all has loads of range in it. Take some of the dirtier work away from the mason, because hand-on vibration and dust are all in it. You'll all see everybody wears a mask here. Ventilation is absolutely paramount because sandstone is highly dangerous for our lungs. An Edinburgh mason was famously in the 1800s. An Edinburgh mason would have been finished his working career by the age of 35 and would have been dead by the age of 45. That was standard. And they encouraged them to grow a very bushy beard because they thought that would help filter it. We didn't really. That's that. I'm going to fold up and then see a detail work in sandstone are synonymous with different types of pattern dressing. And those things are because if you go back to 1600, 1700, this down at the other sawn off cuts you saw, they are taken in, they are guillotine split, and these guys square them up with hammers and chisels, and they make this product here. So it's random in height, random in length, it is a mix of all the buff colours or all the red colours. It is sold typically for about £45 a square metre. So it's very cost effective, it's cheap for brick. An average brick these days is 60 quid a metre for a cheap brick. Stone that we think of as expensive is actually cheaper than brick at this point. It's squared up, and if we go look over here, we'll see some real skill. This is real skill with very rudimentary tools how to move and shape these stones. They all go into a conveyor belt and they go for a tumbler to just tumble the edges off so that they look a bit older. It's just a fashion thing. So they're looking at which way the bedding is, they're making decisions about all of those stones all of the time. And let me say to you that the best masons that we have always start their careers in here. This is fundamentally the absolute essence of how to work stone, because they only have one chisel, one pitching tool, one hammer, one punch, and they make all of their decisions based upon those most rudimentary tools. You see the guillotines have like piano key tips on them so that they can work with the stone and get the best split possible. And by the rollers and the conveyors, we're minimising manual handling as much as we can. We're trying to lift nothing. You get some really nice walling stone and a waste product in our own processes. You would have seen these guillotines at Denford as well. So the only waste product is what ends up